So thanks a lot for being here. It's been a great privilege to present my ideas at MLDS conference. In this session, we'll be covering about how to adapt large language models for language like Tamil. In my journey recently, I had the chance of adapting 3 different language models for 3 distinct languages, Tamil, Telugu and Malayalam Llama. So we'll be going over how it can be done, maybe for other languages as well. So maybe one of you in the future could even build your own LLMs. Okay, yeah. So first, before diving deep, let's first look at what, let's just look at a glimpse of what Indic language models can do. Let's start with Tamil Llama. Here's an example of one of my conversations. It is based on Meta's Llama 2. Llama 2 was released in July 2023 by Meta. It marks a significant milestone in open source language models. It was one of the most important models that have come out in 2023, and still to this day, it has been behind much of the progress in the field. So this is based on Meta's Llama 2 model. If you look at an example conversation here, the model, the adapted Tamil Llama model is able to not only respond in Tamil with coherent, it's not only able to coherently respond in Tamil, but also when given at a complex task, a coding challenge, a coding task where I'm asking it to write a Python script to upload a local file into an S3 bucket, it is able to still do it, which is pretty cool, right? And also when we prompt it at what Boto 3 is, it's able to give a decent explanation about what Boto 3 is and why it has used it. So we'll be looking at how this is done, and all of the model, Tamil Llama is fully open source, meaning the code, the data sets and the model is freely available for anyone to access. And also the paper is available. If you want to look up into more technical details of it, you can feel free to do it. And before moving forward, it is worth looking at the evolutionary journey of the large language models. The graph presented here shows the evolutionary journey of LLMs right from the early days of GLOW and Word2Vec to the more sophisticated ones like GPT-2 and also BERT, to even the more advanced models like GPT-4 and more recently Llama as well. There are a lot of models that have been missed out here, which are also very good, like Mistral, Yi from China, and also Microsoft 5.2. But still, this gives you an overall idea about the available LLMs right now and which ones are open source and which ones are not. The ones that are highlighted in dark are open source, and the ones that are not open source. And if you take a closer look, there are a lot of branches here. So some of these branches represent significant leap forward in the field. Like some of the ones are diverged to become create more specialized models, and some of the ones have focused on upscaling the existing language models for a general purpose, like the ones that we are most familiar with, like ChatGPT and of course Llama models. Yeah. So if you look at the Indic LLM landscape today, there are a lot of models. We have seen a tremendous transformation over the past few months. Just 3 months ago, we didn't have a single LLM for Indian languages. And today we have a vibrant community building a lot of LLMs, and already we have a lot of LLMs already there. Let's just go over one by one. Of course, there is Tamil, Telugu and Malayalam Llama, which I had the chance of developing. And there is Kannada Llama, which was there is Kannada Llama, which was developed by Tensovec, and there is also another Kannada model. There are 2 different models for Kannada, which is developed by Cognitive Labs. Those 2 are very good models. Actually, I've tried them, and also, of course, there is OpenHathi, which was developed by Servom AI for Hindi, and also there is Odia Llama, which was developed by Odia Gen AI. So from nothing, in these 3 months, we have gotten to a point where we have LLMs for 6 different languages, which is pretty incredible because these 6 languages are spoken by millions and millions of people around the world, maybe close to 1 billion, I don't know. So but that the story doesn't end here. I know a lot of research is right now being carried out to develop more language models for other languages like Gujarati, Punjabi, and even classical ones like Sanskrit. And all of them are based on Metas Llama. So again, highlighting the importance of open source models and how powerful they are. Let's just talk about a simplistic overview of what language models are. Language models are everywhere in the news now. They are some of the language models are huge, colossal. They have billions of, or even trillions of parameters. When we talk about the state of the art, like GPT-4, we don't even know how much parameters it exactly has. It's estimated that it has more than a trillion parameters. So these are huge, humongous models trained on massive amounts of data, hundreds of terabytes of data, sometimes almost the entire internet. So out of this, when we do this rigorous training process, what happens is that these models form a kind of world knowledge, so which is more powerful because they can now be applied to other downstream tasks like code generation or even creative writing and a lot more. When we look at the diversity in AI, there's a stark difference. So let's go over that. When we look at the linguistic demographics of the real language that are spoken, if you see, Chinese is the most spoken language in the world with close to 1.2 billion, which is actually more than the combined amount of English, Spanish, and Arabic. But still, the representation of Chinese in the digital world, that is in the internet, is only 1.8%. Whereas languages like English dominate with 53%. But the same situation is true for Hindi as well, which has even smaller amounts of data on the internet, with probably even less. But still, it has a lot of speakers around the world. It's one of the most spoken languages in the world. But still, the digital representation is not there. And this is one of the reasons why language models falter when we prompt in a different language. When we prompt in low resource languages like Tamil, even ChatGPT can wildly hallucinate and provide irrelevant responses. If you look at the training language distribution of Metas Llama, which is one of the most significant works in open source LLMs, the same story is again true. English adds up to a total of a whopping 90% of the training data, with 8.4% of the data is unknown, which is estimated to be probably code, and then only 1.5% of the amount here is for other European languages, and only about 0.8% of the training data was the rest of the languages of the world combined. So that is one of the reasons why we don't see good performance in even Chinese. And this also underscores a pressing need for the Indian community to develop foundational language models within India. Otherwise, we will technically be left out, because Chinese already have a very great, vibrant community building a lot of data sets and models. We've started seeing that in India, and I'm sure it will only progress very well over the next few years. When we, I'm taking Tamil as an example, but this is also true for many other languages. When we prompt Llama 270B, which is the largest Llama variant that has come out, when we prompt it with hi, it is not even able to respond back properly. It is translating what we say, but it starts to hallucinate when we ask simple questions like how to fall asleep quicker. And when we go to ChatGPT, the free version of ChatGPT, it is able to respond back in Tamil when we greet it. But when we ask the same question to ChatGPT, it is able to produce a response. I'm not sure if you could see this, but it is able to produce a response. But the words doesn't make sense, and it's totally incoherent, and it doesn't make sense for a lot of sentences. Doesn't make sense here. When we go to GPT-4, however, GPT-4 is very good in a lot of the languages that I've seen. GPT-4 is very good on English and Tamil and even Chinese. That highlights the fact that GPT-4, the scale of GPT-4, and also the amount of curation that went behind developing this model. They have made it in such a way that even a large model, more than 1 trillion parameters, can be made multilingual. Whereas ChatGPT, the direct precursor, is not able to do it. When we let's talk about Llama models, because that is what we are going to adapt for other languages in this session. Llama was first introduced in early 2023, which was again a huge milestone for the open source community. This was one of the first language models that seemed promising, and there were a lot of models coming out of Llama as well. But Facebook followed it up with Llama 2 in July of 2023, which had significant differences when compared to Llama 1. If you see, the context length is now double the size of the context, and also they've trained it on almost double the amount of data. And that is, there were also obviously changes to the architecture, but if you look at the performance of Llama to other models at that time, this is taken directly from the paper, Llama 2 outperforms almost every other open source LLMs at that time, and also it came very close to ChatGPT, that is GPT 3.5 Turbo. I'm talking about the Llama 70 billion parameter model. Let's first understand how a language model is trained. Llama follows a simple recipe that most LLMs follow. They first undergo a massive pre-training stage where they are trained on massive amounts of internet data, web scrapes, and all that. And Llama was trained on 10 terabytes of data, and then it was trained for a lot of days. There are 3 different variants: 7 billion, 13, 34, and 70 billion parameter variants. And they took up a whopping. The GPU time for that is absolutely huge, and they have estimated to be spent around 20 million for the development of all the Llama models. It's just an estimate, we don't know, but and then the next stage is obviously supervised fine-tuning, where we adapt the models for to respond back to human instructions more accurately. And then they also did RLHF to make the model follow human preferences better. And that's the blueprint for training many language models today. And we are going to follow the exact same approach, but with an important difference. And one more thing that I like this is not possible for most of the people, or even most of the companies, because spending 20 million and thousands of GPU hours and millions of dollars is not possible for even most of the companies. Only tech giants are able to do it. So that is why the strategic importance of adapting this existing open source LLMs to other languages comes in, because we start from scratch and about building an open source LLM. It's going to take a long time. Only large tech companies are able to do it. But what if we could adapt these models for Tamil without much? By spending just a minuscule amounts of money, and also with relatively modest amounts of data. That's where this session is going to lead next. And these are some of the challenges that we face. First, of course, there is a lack of quality data sets. While there is a lot of data on the internet for many Indian languages, most of the languages have either only news content or Wikipedia, which is not sufficient to train an LLM, but even the news content is not as high as we have in other languages like English. So, and even some news content does have English or Romanized words as well. So that could even become a problem. But for the most part, if you do careful, not even careful filtering, just basic filtering, we could filter out the pre-training data and then have a decent starting point where the pre-training is possible. Since we are just adapting existing models, we don't need massive amounts of data. From my experience, like 12 gigabytes or even 6 gigabytes of data has led to pretty good results. But the problem comes when we are fine-tuning it. When we are fine-tuning the model, we don't have any high-quality data set like we have in English. We either have to rely on GPT-4 to generate instructions by itself using self-instruct or evolve instruct or whatever. And the next problem is when it comes to the vocabulary of the existing models. The existing models, even like GPT-4 and Llama, have almost no words in the vocabulary for Indian languages. So that's a major limitation because that's going to affect the generation speed. If the word is not in the vocabulary, obviously it's going to look at the byte pair encoding. So that's going to make the process very slow. And the next thing is when you don't have existing words, the words in the vocabulary, it's going to be very difficult for the model to learn. And lack of evaluation data and benchmarks as well, like how we don't have high quality data for fine tuning. We also don't have any benchmarks right now, standard benchmarks in Indian languages, which is one of the major areas of concern, because even if you are able to build a model, you will not be able to show any results of, because you are relying on human perception to understand whether the model is doing good or not. That is one of the major concerns. And when we look at other LLM tokenizers, the problem is even more clear. So when we look at GPT, the GPT variants of models, I'm just giving a sentence called sky is blue. The same in Tamil and Hindi as well. The character count is almost the same. But if you look at the number of tokens that are required to represent that a tiny amount of information, it's 5 tokens for English. But if you look at Tamil, it's 25 tokens. And for Hindi, it's 16 tokens, which is almost 4 and 5 times higher than the number of tokens that are required to represent English information. So that's the problem here. This is also true for Llama models, although slightly better. It still doesn't have a lot of Tamil or Hindi words in the vocabulary. And this is the most popular way to adapt LLMs for other languages right now. And this is exactly the same procedure that I followed, except there is one change. I'll let you know that later. First, we expand the vocabulary, since the existing tokenizers don't have enough words in the vocabulary for Tamil or Hindi or whatever language that we are choosing to adapt them for. First, we need to expand the vocabulary. This is actually optional. It is also proved by some other researchers that expanding vocabulary will interfere with the already learned knowledge of the model. So even without expanding vocabulary, it is possible, but that will again be a problem when you cannot generate text faster. And continued pre-training. So we don't pre-train from scratch. If we take the Llama model, we initialize it with the trained weights, and then we continue the pre-training. We need to know what the learning rate was and all that. We'll take a closer look at the paper and find those parameters, and we can start pre-training. There are a lot of complicated approaches being followed here as well, like OpenHati, which was very interesting. They had followed a bilingual next token prediction task. And there are a lot of complicated approaches, but I stick to just continued pre-training with relatively high quality data. So with what we cannot create new data, so we have to make do with what we have. So continued pre-training stage, I try to filter as much, and we continue the pre-training stage with probably the same settings as Llama. We try to keep it simple as possible, and then for instruction fine-tuning, this is again an area of where we need a lot of people working on, because instruction fine-tuning today largely depends on translations, translating existing high-quality English instructions to other languages with a few checks in place to not translate something like code, because you cannot translate that. The instruction fine-tuning is other major challenge. We are right now, I don't think we have any high-quality instruction datasets. And after expanding the tokenizer, if we compare the performance of it, here's an example sentence in Tamil, which is about 67 characters in length, and it takes the original Llama model 89 tokens to represent it. If you take a look at what are the tokens here, most of them are just the byte representations. And that is exactly the problem that we discussed. This will slow down the generation by a huge amounts. And after expanding the tokenizer, we get to 18 tokens. With just 18 tokens, we are able to represent the same text. And when we also check out how much tokens are required for GPT 3.5 and 4, it is also high. But you might ask me a question like, if the number of tokens is high for GPT-4, then what's the problem? You could ask that question because it's doing good in Tamil, right? But the problem is that the scale of that model is not achievable for even the largest of tech giants. Example outputs, we'll just take a look at one example output. One from Telugu Llama and another one from Tamil Llama. If you take a look at Telugu Llama, it's a simple question. If some of you can read Telugu, I cannot, certainly. So here we're just asking about AI. The model is able to respond back in fluent and coherent Telugu about how AI can benefit humanity. And for Tamil, for the Tamil, we have two different models here, the 7 billion, 13 billion parameter model. We just give a simple reasoning task, and then it is able to complete the reasoning task and also give clear explanations in Tamil about how to solve these. And what are the alternative approaches to this? So we have expanded the tokenizer, continued the pre-training, and then we do the fine-tuning stage. But what are the alternative approaches? As I said, choosing not to expand vocabulary is one way. That way you are not going to disrupt the already learned representation of the model by much. But it slows down your training and also the generation speed by huge amounts. So that's one of the areas of concerns. But still, vocabulary expansion will help in very large scales. Now we are just training on few gigabytes of data. When we increase the scale, of course, the model is going to learn more about the world and for direct fine tuning. So you might ask the question, why not take Llama and without performing pre-training, why not directly fine tune it on a Hindi or even any other language data set? That doesn't really work out that well because the model will still struggle to form sentences. That is also coming from my experience, also from the experience of many others in the field. This could work, but for this to work, if you're fine-tuning it for something like French, which already had a decent amount of data, it could work out for languages like that, but for low-resource languages like Tamil, Telugu, Hindi or whatever, this technique will not work. And what about the original English capabilities after going through the adaptation procedure? So here, if you can read about it more in the Tamil Llama paper, it's mostly what we have discussed here. But still, there are a few tweaks. I've performed a task called DPO, Direct Preference Optimization, for all of these models. So after DPO, the models are either match the original Llama's performance or they perform better. This is also true for all of the languages that we see here: Tamil, Telugu, and Malayalam Llama. So the original English performance is not altered by huge amounts. In fact, it's doing slightly better. And what are the limitations and potential next steps? From this talk, you might already have found some limitations. But one limitation, the first limitation is the constrained knowledge base. Since we are not training on huge amounts of data, like ChatGPT was trained on almost the entirety of the internet, we don't have that much to work with. We are relying on the existing model's knowledge, and we are trying to adapt that for a new language. So the knowledge base might not have some obvious informations like the cultural information. That's one of the problems that I faced, and what I did for that in the fine-tuning stage, we introduced more samples that can solve that problem, like specific questions about the culture and the festivals and all of those things. And the second thing is ethical concerns. So these models are not censored. So if you ask it a question, a very harmful question, it will most probably answer that. And the third is hallucination. Yes, it can hallucinate like any other model. And without doing this fine tuning and all that, without adapting it, you'll find the hallucination rate to be much higher than what it is. So although hallucination does exist, but it's not at very extreme levels. For reasoning and mathematical challenges, although it can solve some basic things, it does struggle with very complicated reasoning and mathematical tasks. That could be solved by high quality instructions in that language. More data on that would also help, because while translating, we just filter out most of the too much scientific instructions, because translating them doesn't really convey the same meaning sometimes. So that is also one of the reasons. And evaluation hurdles we don't have benchmarks for evaluating. That is one of the major concerns. For English, we have a lot of benchmarks like MMLU, AGI eval, HELLASWAG, Truthful QA, that measures different aspects of the model. But for Indian languages, we don't have even one yet. And Chinese have a lot of, although they are also developing models for their own language, they have benchmarks as well. But benchmarks cannot be built by a single person or a couple of persons. Benchmarks have to be built by experts, probably curated by a lot of people, so that it measures the ability of a model in that language pretty well. And also there is translation loss. Since we are translating most of the inputs given to a model in fine-tuning stage, translation isn't perfect, right? So there is a problem there as well. Because of translation, sometimes the model can output responses that look more like translated text. So, and inability to respond in colloquial form. This is not a problem for all the models, but some models, especially the ones that I have developed. So we cannot interact in Romanized form, and also we cannot interact in colloquial forms. For languages like Tamil, we have almost slightly or even totally different way of writing it formally and communicating it in a casual form. So since translation everything gives you formal form, most of the data, even 99% of the data on the internet is in formal form. So these models have not seen any data in casual form of the language. So that is one of the other issues. Yeah, so I think that's it.